We're going to talk about conic sections, specifically circles. Conic sections is a cross-section of a cone, or in other words, the intersection of a plane with a right circular cone. So if we cut it parallel to the bottom, we get a circle. If it's a little bit slanted, we get an ellipse. If it's more slanted, it's a parabola. And if it's perpendicular, we get a hyperbola. So the first we're going to talk about is a circle. And so take a minute and just think about all the things you already know about a circle, how it's rounded, the circumference, the diameter, the radius, the area, center, just all those vocabulary words that you know it's related to the unit circle. So you already know a lot of stuff about a circle. And so the formal definition is the locus, or the set of all points in a plane whose distance from a fixed point in the plane is constant. So you got the center, and then you got a point on the plane, or the point on the circle, and it's the same distance all the way around. So we call that distance the radius. If we use the distance formula and we say that the center is hk, but we call it x1 and x1, y1, and your other point is x2, y2, we can actually derive the radius. We can use that distance formula and we can actually get the radius. If we rearrange that distance formula a little bit, we actually get the standard form equation of the unit circle. So if we square both sides, we call the distance a radius, and we change out our x1, y1 to our hk, we actually get the standard form. We also have the formula for area, circumference, diameter here, and also for your arc length and your area of a sector. So if we run through a couple of examples, the first one, what is the equation of the circle with center at 5, -2, and radius of 6? So we want to identify the important information. So our 5, -2 is our hk, so h is 5, k is -2. Our radius is 6, and so to write the equation, we'll start with the standard form. We'll plug in the information that we know. Be careful with your signs, and then simplify. That's all you have to do for that one. So your answer is x minus 5 squared plus y plus 2 squared equals 36. Example 2, what is the equation of the circle with a radius of 5 and the center located on the x-axis where x equals -3? So we'll again identify our important information. The radius is 5, and if the center is located on the x-axis, we know our y value is 0. And we know that our x is 3, so our center is at -3, 0. And then we'll start with our standard equation. We'll plug in all of our information. And we end up with x plus 3 squared plus y squared equals 25. Next example, write the equation for the translation of x squared plus y squared equals 4 by 3 units right and 2 units down. Sketch the original circle and the translated circle, and then find the distance between the two centers. So lots of information. So first thing we'll do is identify some stuff for circle 1. So my equation is x squared plus y squared equals 4, which means that my center is 0, 0. If r squared is 4, that means my radius is 2. And then we'll go ahead and plot it. So you want to put your center at 0, 0, and then go a distance of 2 units in every direction. So you want to kind of keep it on those grid lines. So I would go across the x-axis both ways and across the y-axis both ways. Then we move that center 3 units to the right and 2 units down. And so your radius is still the same. And we find that the center is now at 3, -2. Radius is still 2. And then finally, to fully answer the question, we have to find the distance. So we'll use our distance formula. I was using Google Slides, and they don't have a very good equation editor. So I went ahead and squared both sides. So my distance squared equals x1 minus x2 squared plus y1 minus y2 squared. It doesn't matter the order of your x1, y1, as long as your first x, y values are in the same position. So x1 and y1 are in the first position. So then I plug in both of my points, and then I simplify and solve it, take the square root of both sides, and we find that the distance is about 3.61 units. Example 4, write the equation of a circle that passes through the point 6, 4 and has a center at 2, 1. So my point 6, 4 is just xy and my center is still hk. So then instead of plugging in my radius, I just plug in a different set of points. So in the end, I really should only have one missing variable. So again, my 6, 4 is just a regular point. It's just xy, plug in my hk, and I'm solving for r squared. When I get r squared, since that's part of the equation, I don't actually have to solve all the way for r because the question is not asking for what is the radius. Easily, you could tell me the radius is 5, but you can just stop at r squared. And then we're going to plug it into the standard form equation. So standard form, we have our x and y variables. That's what will graph for us. And so if r squared is 25, we just plug it straight in and plug your h value in and plug your k value in, and that's your final answer. Then we have to write the equation of the circle whose area is 36 pi and the center is located at square root of 5, negative 3. So we know two things. We know the center and we know the area. So using the area, we know area is pi r squared. We can find the radius, which we do need for our standard form equation. So we'll have 36 pi equals pi r squared, divide both sides by pi, and we find that r squared is 36. Again, we could identify that the radius is 6, or we can stop there since that is what is in our standard equation. Then we'll start with our standard equation, plug in our known values, and we've got our equation already. Don't have to simplify it further than that. And then finally, we're going to write the equation in standard form by completing the square. So we start with x squared plus y squared plus 4x minus 6y plus 8. I have the steps written out. Basically, we're just completing the square twice. We're completing the square with x, and we're completing the square with y. So first thing we're going to do is group the variables together. And so we'll have x squared plus 4x and y squared minus 6y equals negative 8. Leave a space after your linear term because we want to write the completing our c term. So then we're going to complete the square. If you'll remember way back when we actually did this solving quadratics, you take your b value, cut it in half, and square and add it to both sides. So my b value for the x is 4, half of it is 2, 2 squared is 4, add 4 to both sides. Do the same thing with y. So my b value for y is negative 6, cut it in half, negative 3 squared is 9, add it to both sides. Once I do that, I'm going to simplify. So if I factor the x squared plus 4x plus 4, I need a perfect square binomial. So the same thing squared gives me x squared plus 4x plus 4. So that would be x plus 2 squared. Do the same thing with the y. So y minus 3 squared. And then simplify the right side. So negative 8 plus 4 plus 9 gives me 5. If you'll notice, that is the standard equation of a circle. And from that standard equation, we can get our center and our radius. So center is HK, H is opposite, and H and K are both opposite. So we'll have negative 2, positive 3, and then our radius is the square root of 5 because r squared is 5, so just the plain old radius is the square root. And that is enough to get you started for circles, and we'll talk about another conic section next.